before I start, I just wanted to mention I'm quite impressed that you've been able to see both Texas and Nebraska folks in the same room. This truly is a cooperative forum setting. Not that I live in big red country or anything. As sort of a preamble, even to my giving a background to my agency, because I think it's important to give a context of what information I'm providing comes from. Related to my bio, my focus is on the preservation primarily of observational science records from aerial photography going back to the 30s and satellite observations, elevation data, and land use line cover data. You didn't hear the word water in that short summary. My agency does a considerable amount of water, so I had to study up on my colleagues' approaches, and my objective today is to provide you information on the depth and breadth of the water products, services, and data that we can and do make available on a regular basis. The agency goes back to John Wesley Powell as first director. So we have a long history starting with water, including gauging discharge technologies, which use floats and all sorts of what we would think antiquated devices, and realize the importance, starting of course in the east and working west, of determining what are our resources from a hydrologic standpoint, and then trying to model those, and then including the groundwater, which came a little bit later. The agency has a cross-disciplinary support, and it gets into biology, geography, that is the mapping of cartography, hydrology, and then biology also. 9,000 employees, which are distributed quite a bit throughout the nation. My dot would be the most eastern portion of South Dakota, where 600 staff work in a national facility. A lot of cooperation goes on, especially in our water resources areas with the state elements. That's also the case with geological elements. We'll work with state geological societies, but the water probably has the largest contingency of cooperatives with the states of any of our science disciplines within our agency. I wanted to give you sort of a structure of our agency. As of October 5th of this month, we're officially realigned, and it is the most change I've seen in 25 years of being associated with Geological Survey. We have a new director, and she's aggressively transforming us to be more mission-aligned to our science, and that will strongly include water. You'll notice she has an element with water in some of her past experiences. She's highly respected. This is our old structure, which was based on these disciplines that I mentioned: geology, hydrology, geography, and biology. Fairly flat. This is the new structure. The point maybe for you as a takeaway is that water is the only element that is one-to-one mapped into the new structure. So that really doesn't change. The rest of us are still trying to figure out how we can best contribute. This is the thrust that I want to get across to you. The tools and services that may help decisions, may form part of that history, may help that principle of sustainability that we've heard about in the keynote speak on, that I think relates directly to our daily lives. It will be hopefully a change of experience. I still recall and mentioned to one of our participants earlier before the meeting started my first experience in a California hotel a couple decades ago, where in the shower I gave recommendations for length of time and turning off the water while I'm lathering up. Things I had never considered coming from the Midwest. And it really hit home how serious that issue was. Real-time data, and these are what my hydrology colleagues have categorized their products and services and data streams as. It's probably more near real-time data. The data are recorded real-time in 15 and 60 minutes and sometimes even minute increments. Then they're reflected back up through various means, even analog modems, that we still migrate to faster means, satellite telemetry streams, utilizing some of our own satellites and those from the NOAA agency. And the good thing is once they are relayed, it is literally minutes when they're on the websites. And we have found out, primarily from recreationalists, when we would maybe take a site down for some management or some updating of software, within an hour or so, the phones would start to ring, and that we wanted to know the stream level or the volume discharge at a certain site. In this case, it was primarily recreational uses. That they wanted to determine if they could go out kayaking that day or not. We did not develop the tools for that means, but we found we had a large recreational following. This is just a snapshot of one day when I did this presentation, or putting this presentation together, showing above average and below average stream conditions. So it's just streams, one day, snapshot. This sort of information is dynamically available on this sort of basis, and then also summarized going back on month and year and multi-year basis. Narrowing in a little bit further, I just chose Colorado as a geographic location. You can get some of that same information, and these are deviations from normal, to give some ideas, and then I'll just zoom into the blue dot that happens to be showing quite a bit above deviation from normal. And this information on the website only comes about if there's been at least a 30-year history. So while that's a relatively short amount of time from the nation standpoint, from a recorded element, it's a relatively long period. And you'll note the word provisional, and that's, as I've learned, it doesn't become official until they do the annual report. And they go back and they do some test analysis to make sure some figures were right, especially if they're significantly different from normal. But they are published annually, and only then are they considered official. But obviously we use these, especially with spring, with National Weather Service on a real-time basis in lots of situations, but the word provisional means it has not been gone through our own peer review cycle and then published officially. Also want to indicate that when you start to drill down, in this case, it's not just what they're calling real-time data. You can, as the drop-down indicates, get at all of these other elements that I'll explain separately. You can get at them dynamically at this point, too. So it's actually a deluge of information, and it would probably take someone who really wants to know what's going on to figure out, okay, I'm really interested in the water quality, or I really need to know stream volumes, or maybe how are these well depths changed for water contact over time. Maybe that's telling me the water table is dynamically changing. So this is that one site, and it looks to be a relatively flat line for about a week's worth of coverage. But notice the triangles on the bottom, that is the average flow. So this is significantly above that, and then the table is indicating it's almost near the all-time high. So this September on that point on that stream was actually a significant flow. And you can download this data if you'd like to do your own analysis or add it to maybe some of your own information that you've been accumulating. Site inventory is primarily about streams. These are points, some regions, that is what a stream is encompassing for its flow, wells, test holes, and these can be our own or other holes that are private property that people allow us us to take measurements. Some springs, a few tunnels, lakes, reservoirs, ponds, 300 elements to make up what our hydrologists call site information. And this allows you to filter down if you want to just make your result a little bit more focused, but also you can keep it at a higher level and search for all altitude elements. I could just search as an example on well depth if I just want to know, can I tell in this part of Colorado that in general the water table based on well depths is going up, down, remaining stable, or whatever. I typically would just use the lat long box because I'm going to focus in a geographic area. And you would get back information like this, immediately tells you the well depth in hundreds of feet. And then you can zoom in for additional information at that point. And notice we're already talking about a cooperative effort here with the state. And in this particular well, this is a cycle representing about 12 years. And that's probably a normal cycle for that, going through the annual seasonal variation that would occur in this area. Looks like 2002 had a low point, but also 2010 is not done yet, and I'm wondering where that's going to bottom out. It is getting comparable to a low point on that particular well. So now stream information versus a well can get into immediately some quality elements. And these are just a few. You can see we're starting to analyze for heavy metals. And you could also do some points up and down from maybe a city to determine, below this city we're getting higher rates of this heavy metal, above it we're not. Might be some correlation with that urban area going on there. Surface water we use for uplinks. The Department of Commerce, NOAA's GOES satellites that they allow us to use uplink and downlink capabilities. And typically we're compiling a day's worth of readings. And then as I mentioned, we'll annually compile the information, peer review it, and then publish it. Time series are just really those minute, 15 minute, 60 minute, whatever the cycle is that's available locally. And then from that we can get into the various variations from median, maximum, minimum. Gets back into the provisional data. And I'm reading all of the words, but I wanted to provide it in the PowerPoint so that will be as a reference material to you after the fact. These are just some of the characteristics that you can go further on into getting additional charts, getting raw data that you can download into a spreadsheet format and then manipulate as you would like, maybe adding your own factors that you have maybe even more local information on. So you can see it's daily, monthly, and annual. So depending if you're really trying to figure out, well, how have we been doing this growing season? Or, well, now I want to compare that to the last 10 years. You can get into that through annuals. And then look at peaks. And then also water quality. The annual on the bottom left, the annual report is what is published. And by published, it used to be traditional only paper. We have gone to electronic, I believe exclusive. I don't think we even supply paper anymore. So this would be just a seasonal view of a stream. This is probably a typical pattern for Colorado with the spring, early summer rains. I know in South Dakota we had much more summer rain than we've ever experienced. Looks like July still had a fair amount in this area, but now tailing out significantly. And then again, is something that could be used in a comparative fashion. Is that typical? Or over the last 20 years, are those peaks different? Groundwater, we have several 100,000 wells, springs, test holes, and even excavations that we have access to, and they're probably for a longer term, not something of a relatively short nature of maybe rebuilding a road and it will be smoothed over. Groundwater is based on hydrologic units and then hydrologic unit codes, which are hierarchical bases to describe water features, such as a stream. You would have a first, second, third level stream that might feed into, it would basically be like a tributary system of the Missouri or Mississippi rivers. And you can then zoom in down in for all of the information at that level. Water quality, we actually work in cooperation with EPA. They don't have blanket wall-to-wall coverage, but where they have bad cleanups, especially Superfunds, they'll even go beyond our water quality analysis, so it makes sense to correlate and cooperate with them. We do have several million records going back, and these are all online since 2005. I suspect we have records going back farther, but probably people that are catching up to a digitization project. And they were referencing the EPA's system called Storm. And if you really want to go beyond, and there happens to be a Superfund or a test site that EPA is doing, we'll link you to that so you can get even beyond our readings. So in this case, here is an example of various rivers at different locations. And selecting one, you get to summary information, and then you begin to see some of the elements that are reported on. Quality is even related to temperature. We talked a little bit this morning about global warming and climate change. And this is one area. Water changes more slowly, but if it does change over time and it's repeated, then that has been a significant event. Not seen here, but this goes on for several pages worth of elements. So again, it would be depending on what your researchers would be interested in. Maybe they really only want to know about ammonia. Maybe there was a discharge several years ago, wasn't followed up to their satisfaction. They can try to do some of the research themselves. We get involved in legal cases to a great extent, not because an agency sued, but because they want the defendants, typically, or the prosecution, want to prove a point and try to use our science. We don't take sides, we just provide what they would like to know as far as what their perspective is. So I've tried to bring in as my main point some of the breadth and depth of a system that really would take several hours to feel comfortable with, but also realize that you can download the data so that you can maybe get to different conclusions based on additional information that you have. We relate to other agencies like EPA for even expanded information that could get into several hundred elements for a specific site. I believe you could probably just Google NWIS and make sure the last part of the website is .gov. We have that. Some interesting other sites that take advantage of government needs, and .com comes up first. All of the information I showed you is online and public. There are also additional references on almost every page. If you had a question about what you were seeing or interpreting, you could get to a scientist that would help answer that. Again, near real time is probably a better term for it. It's not instantaneous, but it's probably within an hour in most cases. Some sites that are maybe a few years old in technology might take up to 4 hours to get us that to a manual. We are updating those. I'm a minute over my targets. Thank you. questions later? Was that, or questions now or later?
Well, we could take a question or two now, but
I don't want to be out of line.
you're the boss.
Ernie Riley from CRL. John, I wonder, with the emphasis on generating real-time data, there must be a lot of retired data that's in possession of the USGS as well, since it's always being replaced and it must be older time information. The electronic records archive project at the National Archives Records Administration is supposed to address retired government information, retired government-produced information. Can you talk a little bit about the relationship between that and the USGS retired information?
Yeah, in fact, I personally work with the National Archives to a great extent. Had meetings with them yesterday as I was coming out here. And the Electronic Records Archive, to summarize, their goal is to address any record in any format forever. That's almost literally their objective. If you think about that, that's a daunting element. They have allocated around $500 million to that effort. And that is to come online in stages and starting last year. To be honest, I don't think they'll accomplish their goal, but I think they'll get a long ways towards it. And all of our records go through, every federal agency must have a record schedule. It's required by law. It wasn't required to keep that schedule until today. It is, as of last year, 2009, every federal agency had to update their record schedule. And that includes our water records. Some of our water records, even some that I described today, are considered temporary. The 100-year temporary. I suspect that they will be revalued at permanent level in the future. And that's why these records would ever go away. The records that are not visible now are in paper tabular formats now, and we're still going through a digitization project. We have a data rescue effort within the USGS that I actually initiated about 5 years ago, and water records are a big part of this. We've dedicated several $1,000s. Texas was a test pilot last year, and several water records were recovered. But we have recording stations in every state, so we have a ways to go. And then that will all make its way to the National Archives.